Hello everyone, I'm Paul Comanici, Principal Engineer at 8x8, and today I will talk about from code generation, orchestration to cloud, from code generation to orchestration, cloud at scale. We'll explore how cloud code can handle sophisticated multi-step tasks that go far beyond simple code generation, and I'll be working through some patterns and techniques for complex task automation using real-world orchestration. Here's what we'll cover today. We'll start by defining what complex tasks actually are and why that matters. Then we'll dive into code capabilities that make tasks possible. We'll explore some advanced patterns that you can apply immediately. Let's start by defining what makes a task complex. Complex tasks require multi-step planning and execution. They're not just about generating a single piece of code and answering a question. There are workflows that span multiple phases, require coordination between different systems, and need to maintain context across extended interactions. But that's just the beginning. Complex tasks are also require context preservation across interaction. Think about a development workflow. The decisions that you make during requirements also influence your architecture, your testing, then impact your implementation approach. Without persisting context, each step starts from scratch. They need sophisticated tool orchestration and integrations. We're not talking about using one tool at a time. We're coordinating between different tools like Jira, GitHub, SonarQube, and whatever any other tools you are using. And error recovery to adapt to critical scenarios. When something goes wrong, and it will go wrong, be prepared and have the system in place to adapt and to recover. Finally, quality gates and validation. At each step, we need to have quality gates put in place, and those will represent the guardrails of your system. Maybe this is the most important step, and maybe you should start from here, as this will allow the AI to automatically fix himself. Now let's examine the core capabilities that make complex tasks possible. First, multi-step planning and execution. The traditional approach looks something like this. User requests build a user authentication system. AI attempts to handle everything in one massive response. Here's some code for login functionality, and that's where it ends. The user gets fragments, not a complete solution. Claude approach to complex tasks is split in 6 parts. Analyze the requirements and constraints. Second, design the system architecture. Make the high-level decision about how components will work together. Third, plan implementation phases. Determine the order and dependencies of the work. Fourth, execute the quality gates. Implement each piece and validation checkpoints. Fifth, test and validate, ensure everything works as intended. Finally, document and deploy. Make the solution ready for production use. I may need to add here that at every step, they can go back to phases in the past. So let's say test and validation, they can go back to the implementation just because something fails. This approach gives us several key features. To-do tracking provides visible progress management. You always know what's done and what's coming next. Phase gates create quality checkpoint where we validate before moving forward. Context preservation means information is not lost between steps. This brings us to our second core capability, context preservation and memory. Most AI systems treat each interaction as completely isolated. This leads to repeated analysis of the same code base, lost context between related tasks, inconsistent decision making, and massive waste of computation power. Imagine if every time you work on a feature, you had to relearn the entire code base from scratch. That's what happened without proper context management. And the solution to this, at least our solution, is to have a way to persist the context. Think of the decisions that you take during the development, think that the decisions that you make during the planning, think the decisions that you made during the years, and so on. Plus, you need to have status for all of your stages of the development phases. The benefits are substantial. We get efficient handover between specialized agents. Each agent can pick up exactly where the previous one left off. We have consistent decisions across workflow phases. Quality tracking with explicit gates ensures nothing falls through the cracks. And we maintain a complete audit trail of the implementation choices for future reference. Let's look at how this concept works in a practice with a real-world implementation. The orchestration workflow system uses specialized AI agents which working in harmony to address several major challenges in development workflows. Manual workflow bottlenecks from requirements to deployment, too much time spent on process instead of value creation. Context loss, where information gets scattered across tools and conversations. Quality gaps from inconsistent review standards and review fatigue, too much noise, not enough meaningful context. Let's walk through the agents in the requirements and design phases. The context analysis provides system context for informed decision making. The deck spec creator takes approved product requirements and creates comprehensive technical requirements documents. The tech spec validator validates those technical specifications to ensure they're ready for implementation, and the task planner breaks down the appropriate technical requirements into concrete implementation tasks. In the implementation phase, we have language-specific implementation agent, the JS. Here I have no specified. Okay, the JS code implementer, Java code implementer. Basically, you can have agents for every language or technology stack that you can think of, and they provide quality assessment for clear pass-fail decisions. Finally, integration and quality. We have the commit creator, creates professional commits with full context. The PR creator generates comprehensive GitHub pull requests with proper formatting. JS reviewer from the implementation phase analyzes the code and stores feedback locally. The feedback publisher then posts the review comments in the PR. Let's move on to advanced pattern you can apply. Complex tasks often involve potential destructive operation, file modification, system configuration, and external API calls. The challenge is how to let AI perform this operation safely without risking unintended consequences. Plan mode solves this with a simple four-step approach. First, analyze the requirements. That's a read-only process. It does not change anything, it just analyzes. Our second step is creating a comprehensive plan. First, presents the plan to the user for approval. You have full transparency about what will happen. Fourth, execute only after explicit confirmation. This gives user complete control over the entire flow. The benefits are significant. First, you have safety, no unintended modification, transparency, everything is clear, understanding of actions, control, user maintains decision authority, confidence, know what happens before it happens. Some practical tips for getting the most out of the plan mode. Use phrases like prepare to discuss or think hardest to trigger deeper analysis. Ask for overviews of what's about to happen. Request function names and brief description of what they'll do. For testing, ask for task description and brief summaries of the behavior they'll cover. Our second advanced pattern is sub-agent delegation. The traditional approach is to try to handle everything in one large prompt. Analyze requirements, decide system, implement code, review quality, create PR, and handle any issues. This leads to context overflow, inconsistent quality, and no focus. Our sub-agent strategy breaks the task down into experts. The product reviewer validates product requirements, task planner breaks down the technical task, JS implementer creates product JavaScript code, JS reviewer provides critical code quality assessment, PR creator handles professional GitHub PR creation. Each agent has deep domain knowledge in their specific areas. And design principles are crucial. Single responsibility, one agent has a clear purpose, it has deep knowledge, it has a clean handoff structure, and focus on the quality. The third advanced pattern is MCP integration for external systems. I will not dive deep into this part. MCP stands for Model Context Protocol and allows us to integrate with systems with proper authentication and error handling. Think like Jira integration, GitHub integration. Everything that has an API, you can easily create an MCP server that you can afterwards use for the integration. Now let's talk about best practices when to use complex task pattern. These patterns are perfect fit for multi-step workflows with dependencies when one step output becomes the another step input. Quality is crucial when mistakes are really expensive. Repetitive expert work that benefits from consistency, integration-heavy tasks across multiple systems, long-running processes that need state management. When I say long-running processes, think like hours, days. But these patterns can be overkill for single-step operation, just generating one function or answering one question. One-off queries or explanations where you want to repeat the process, tasks requiring real-time human judgment, highly creative or subjective work, processes with frequent changing requirements. You should consider carefully the costs that imply versus the benefits. Complex tasks require more resources to set up and maintain. There is the maintenance overhead, where specialized agent needs updates, and also there is the team adoption, training, and change management needed. Let me share some hard-won lessons from my experience. First lesson, test will pass, sometimes with wrong reason. Review generated tests carefully, they may pass while testing incorrect behavior. Green doesn't always mean correct. An example here, in the end-to-end test, Claude wrote something like try, button visible, catch, button not visible. Totally pass. Inside unit tests, they wrote if something, test something, else test something. Second lesson, AI prefers to create new files instead of using appropriate Git commands to move files. It tends to re-implement existing logic rather than reuse what's already there. You need to explicitly guide it towards reuse and proper version control practices. Third lesson, hallucination in planning. Plans may not match, meaning you will do a plan mod and afterwards you'll say save it, and the documentation that is saved does not match with the plan that you seen earlier. Secondly, you'll start doing a plan, you'll stop execution for whatever reason, you'll say continue the plan. No, you'll not continue the plan always unless you really verify that the tasks are the same. Fourth lesson, hallucination in documentation. It may fabricate documentation examples or ignore existing code-based details. It even when correct information is readily accessible to it. As a good practice here, it is recommended to create multiple documentation for it with clear examples, what's correct and what's incorrect. Even those can be ignored, but you need to be careful. Final lesson, make your agents available everywhere. So my recommendation is to use a GitHub repository for your company or however that has all the agents written there. You have versioning control, you have ability to collaborate and so on. Afterwards, in order to have the agents available everywhere, you can create symbolic links from that repository to the Claude directory, so those agents afterwards can be used across all of your repositories. Just as an example, in my company, we have around 2,000 repositories. It will be a nightmare just to work with agents and not have them available for every repository. This brings us to mindset evolution. This shift is significant as this transition from assembly language to high-level languages. It's not about losing skills, it's about operating at a higher level of abstraction where you can accomplish far more with strategic thinking than individual coding efforts. The developers who embrace the shift will be the architects of the AI augmented feature. Thank you very much for your attention. And this brings us to the questions. I love to hear about your experiences, your questions, or the challenges that you are facing. By the way, the presentation was totally generated with AI, gamma.app. I really recommend it. This is, I think, my best presentation that I did until now. Bad with design, bad with styling. I think they did a good job. You can provide feedback on that. So, yeah.
Here. So, at some point you said that we should use the chat config, like you showed us the Claude config. And you said that we should have that on a single repo and use that on all company computers or project specific?
No, so chat, this does not exist. So if you have you used Claude?
Yeah, I was referring to Claude. I use
Okay.
chat as a word for
Okay.
all AI chats or
So the idea
chatbots.
is have a GitHub repository where you store your agents. Now, Claude evolves. So you have agents, you have sub-agents, and you have something with P starts. I don't remember exactly. Sorry?
You have skills now.
Skills, but there is another type of agent that I miss right now. It starts with P, I know, not planner. It's basically a general agent that you can have interactions with. The sub-agents should only work with input-output defined through schemas, and you don't have any interaction with them. The interaction of the sub-agent is done only through the human interaction based on other agents. So sub-agents are independent, they start, they stop, and they just communicate through your communication protocol.
But the thing is, we should have a config in.
Not config. I was saying have those agents in a repository and make symbolic links to your Claude desktop configuration, to the folder.
Okay.
So this way, whenever you start Claude, you'll have all the agents available.
Mm-hmm. Okay, so I misunderstood that.
Okay.
Thank you.
Have you? I mean, you talk a lot about the traditional way versus the this new way. Have you measured somehow the benefits and the gain in productivity, or?
Yeah. Okay. So let's take the last project that I worked at my company. I spent the last 2 months to migrate the documentation from the old platform to a new platform. The old platform was a product from another company that was 120,000 dollars and per year. I did that in 2 months with 4 more people that helped me at most 2 weeks versus that amount of pay that we would have paid to another company. That's only yearly, so plus many years afterwards. Previous to that, I worked for about 1 month to a feature with the product that I estimated to take at least 1 year for a developer, and it's in production. So you can put your salary or whatever it's your income, see what you can produce with that versus take the AI and see what you can produce with the AI. For me, it's at least 10 times. So yeah, the costs of the AI usage plus the benefit, the weight of it, it's unmeasurable.
I was not referring necessarily to the cost, but like
Okay.
traditional way, meaning just prompt it versus implemented this kind of workflow, which is more complex in
Yeah, so
this
what I
regard.
was saying, if you have complex tasks, do what I recommended here, sub-agent, agents, it's a complex workflow. But if you have something simple, work with prompting, but please don't do vibe coding. Vibe coding was there, don't do it. You can do it on your own, test it, see how it works, don't go with production that. You'll get bad habits doing vibe coding. Now, going back, what I said with the quality gates and everything. What you should do is put the guardrails. This is the most important step in any AI workflow, meaning how I described earlier, the tests were always passing. Claude things like, okay, let's write an if it's not that, it's that. So yeah, it will pass. What I did, I created an ESLint rule that does not allow if inside tests. I did not allow try-catch inside tests. So right now, if Claude tries to do ifs, try to do things like that, it will fail. Also, configure your testing tool, for example, to have at least one expect per test, because he will not write any expect and everything is fine. Configure your input to not be equal to your output, meaning expect true to be true. You can write ESLint rules like that. So when you'll put Claude to write your unit testing, he'll do a best job because he cannot fail, basically. So that's the idea. Set the guardrails and afterwards do it. Now, going back to your initial question, do it old way versus new way. Depends on the task. If you have something simple, do it old way. But again, make sure to put what are the acceptance criteria there. Like test should pass, build should pass. Because what Claude will do, it will try to implement, afterwards will run the build will fail, he'll do again the implementation. So it'll continue like that until everything passes. There may be cases, and I happen to encounter that, saying like, I cannot fix the build, fix it yourself. And yeah, it will fail, but I encounter that once per month. So it's very rare in terms of AI working with it. So yeah, hopefully now I responded to the question. Yeah, thank you very much, and we can hear afterwards.